Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling question number 7 from the Eastern Cape media examination, which was written in the year of 2024. Please do expect a total number of 9 videos since the question paper has 9 questions in total. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your final examination. Not just final examination guys, as well as your media examination that you're preparing for right now and the preliminary exam. So please do guys share the video to your peers so that they may have the same edge as you. And please guys, do help us grow the channel by just subscribing. Okay, a helicopter hovers at a height of 30 meters above the ground. It lowers a package of mass 150 kilograms vertically downwards at a constant velocity onto the ground as shown in the diagram below. The tension in the cable is 950 newtons. The tension is 950 newtons. And air friction is not to be ignored. Okay. Okay, over here guys, we are told that this system is moving at a constant velocity. Constant velocity guys in physics, please note that it simply means that acceleration is 0, and when acceleration is equal to 0, it simply means that the resultant force, or F net, is equal to 0. Work net is also equal to 0. The change in kinetic energy is also equal to 0 because there's no change in velocity. Are you together? Please guys, do not forget those things. Okay, 7.1, they want us to define the term non-conservative force. A non-conservative force guys is just a force that whose work done on an object is path dependent. A non-conservative force is a force that whose work done on an object is path dependent. And then now they want us to identify two non-conservative forces acting on the package during its downwards motion. Firstly, we're told in bold letters to not ignore air friction. So we have air friction, number 1. And then secondly, we do have our tension. Our tension is a non-conservative force. Okay, we are supposed to draw a free body diagram showing all the forces acting on the package while it is being lowered to the ground. A free body diagram. Okay, we have weight, gravitational force, which is equal to mg. Remember, so weight is just 150 multiplied by 30. Why am I saying multiplied by 30? Multiplied by 9,8. The mass of the package that they are dropping there is just 150 multiplied by 9.8. This will simply give us a gravitational force of 170 newtons. But remember that guys, they told us that the package is being dropped at a constant velocity. It simply means that the forces that are acting on this package are at equilibrium. So if we have our tension, as 950, that means we have a deficit on the upwards forces, So that means our frictional force should also act upwards. This will be the air friction. I nearly said kinetic friction. That's air friction, That's air friction. Are you together? And obviously our air friction will just be the difference between the two. Our air friction will just be the difference between the two. 1470 minus 950. Ah man, 1470 minus 950. So our air friction, we should get a magnitude of 520 if we are going to be asked. Okay, now they want us to use energy principle to calculate the magnitude of air friction acting on the package as it is lowered to the ground. Okay, I did not use energy principles to find this, né? So now let us use energy principles. You can use, guys, your work energy theorem, but I always prefer using work done by non-conservative forces, especially if I do have non-conservative forces, né? But if I was forced to use work energy theorem, I was still going to do that. So I know that the work done by non-conservative forces is basically equal to the change in kinetic energy plus the change in potential energy. Né? We have two non-conservative forces over there. We have the work done by tension plus the work done by friction. All right, together. The change in kinetic energy is equal to 0, guys. Why am I saying that? Because the object is traveling at a constant velocity. So that means the initial kinetic energy will be the same as the final kinetic energy. All together. So the difference between, there will be no change in kinetic energy. Okay, and then I'll simply have plus mgh final minus mgh initial. Work done by tension, I'll simply have 950 multiplied by the distance traveled is just 30, and the cos of what? Of 180 degrees. Remember that this thing is just opposing motion. All right, together, it was going upwards. So tension, both tension and friction are opposing motion. And then plus work done by friction is basically equals to, we still have a 0 there, né? We have 0 plus the potential energy final. Remember that, guys, the final destination is at the ground. Whenever the package reaches the ground, the height of the package above the ground will simply be 0 meters. And if the height is 0, that means the potential energy is also equal to 0 joules. All together. But we do have the magnitude, we can find the magnitude of the initial potential energy. That's 150 multiplied by 9,8, and then the height was simply 30. So 950 multiplied by 30 multiplied by the cos of 180, that's basically a negative 28,500. Let me write properly. Negative 28,500 plus the work done by friction is equal to 150 times 9.8 times 30. That's negative 4,100. So the work done by kinetic friction will basically be negative 15,600 joules. Né? After finding the work done by friction, we can simply find the magnitude of our kinetic frictional force. How can we do that? We can simply say that the air friction is equal to the magnitude of our air friction multiplied by the displacement traveled. Let me use a different color. Friction multiplied by displacement cos of theta. We know that this will be equal to negative 15,600 joules. Né? We don't know the magnitude of friction, but you know that it traveled, or rather the friction, the objects rather traveled for 30 meters. That's cos of 180. So this will give me negative 30 multiplied by friction is equal to 15,600. Divide both sides by negative 30. And yes, we do get our kinetic friction to be equal to 520 newtons. as I just said over there. Ne? So over there, I just used my Newton's laws, but I was forced to use the energy principles. That's why I had to take this long dry over there. So that's how, guys, you're supposed to find your work done by, rather, your magnitude of friction. Ne? If you wanted to use your work energy theorem, you're supposed to say work net is equal to the change in kinetic energy. Are you together? Work net, guys, is just sum of the works done. Ne? So that's basically work done by gravity plus work done by tension, work done by air friction would be equal to 0. Why? Because there's no change in kinetic energy. Work done by gravity, guys, work done by gravity is the same as the negative change in potential energy. Are you together? So we'll still have negative change in potential energy being equal to work done by tension plus work done by friction equal to 0. Therefore, work done by tension plus work done by friction is just equal to the potential energy. This statement over here is the same as this one over there. Are you together? So you'll just keep on working, going downwards. You'll simply find the same answer. You'll simply find the same answer. That's how, guys, you're supposed to tackle this question over there. So please, guys, do stay tuned and wait for more videos. Thank you.